Hello everyone. So this would be our first lesson in 2026. I will be teaching momentum, as you can see here. Okay, in an horizontal motion, right? So in grade 12 we deal with two dimensions, with a horizontal and a vertical motion. Okay, so that is 2D basically. All right, so we need to first define momentum, and the definition of momentum in the exam guideline says that momentum is the product of the object's mass and velocity, right? And you guys have already seen these two words, mass and velocity, right? And you know that mass is a scalar, and velocity is it's a vector, right? Okay, meaning that mass only has magnitude, and magnitude we know is size, the size of something. That's what magnitude stands for. And vector is something which has magnitude and direction as well. Okay, so mass we know is measured in kgs from grade 10, and velocity is measured in meters per second, and therefore the letter that we're going to use for momentum will be P, and P will be standing for momentum. Momentum will be measured in kg meters per second. Right. So the equation for momentum will be P is equals to mv, mass multiplied by velocity. Why? Because we said momentum is the product of the object's mass and velocity. The product means multiplication. So you take the mass and you multiply with the velocity of the object, you get the object's momentum, right? So the velocity gives momentum its direction. Why? Because mass is a scalar. It does not have direction. So velocity is the only variable here which has a direction. So it will give momentum its vector nature. So momentum gets its vector nature from its velocity, right? So when the velocity is to the left, it means the direction of momentum as well will also be to the left, because it will be given by its velocity. For example, here I gave you an example. A cat of mass 1.5 kg runs at 2 meters per second east. What is the momentum of the cat? And we have to choose direction because we said momentum is also a vector. So east, I take it as positive. West, I take it as negative. And the equation for momentum, we know P is equals to mv, right? So for mass, I substitute 1.5, and for velocity is 2, right? Okay, so if I multiply those two, I get 3, and the SI units for momentum, remember I said is kg meters per second, so I have 3 kg meters per second, but the direction will be east. Remember, when you punch your calculator, you get a positive number, and you said positive here stands for east. That's why I write here east, right? But remember, I already knew the direction of my momentum because my velocity was to the east. So the momentum also has to be east, because the vector nature of momentum is given by its velocity, right? But if I choose the directions here, they can also verify that the direction of my momentum is eastwards, because it was a positive number that I got after punching my calculator. All right, and then if the cat changed direction and moved westward at 1 meters per second, what will its momentum be? Okay, so now it has changed direction and it is actually running westwards. So In this case, P will be equals to mv. M, remember, is 1.5, but now the velocity is -1. Why? Because I already chose my direction here, and I said west will be negative. So when I substitute, I must substitute what? -1, right? And here I will get -1.5 kg meters per second. And remember, I said negative here stands for west. There I will say, therefore, it means my momentum is 1.5 kg meters per second west. All right, I hope it makes sense. So this was momentum in horizontal direction, but it's the same even if I deal with the vertical direction, momentum in vertical motion. Okay, so for vertical, e.g. here, we can have a ball of mass 0.5 kg is dropped from the top of the building and reaches the ground at 5 meters per second. What is the momentum of the ball when it reaches the ground? All right, so we know the equation for momentum P is equals to mv. All right, so I drew like a scenario here to demonstrate what is happening. The ball here is dropped. The word drop means the initial velocity of that particular object has to be 0, right? And it reaches the ground. This is the ground at 5. This is my ball reaching the ground at 5 meters per second. Okay, so I can also take the directions or choose directions. I take down to be positive. This is the direction of motion. I usually take it as positive and up as negative, right? Let me go straight to the calculations. Let me substitute. My mass here 0.5, my velocity 5. Okay, and when you punch your calculator, you get 2.5. The SI units of momentum, kg meters per second, I will take it as downwards. Why? Because I said I take down as positive. So my answer on my calculator is positive. Therefore, I will say downwards. All right. But remember again, velocity was down. It means momentum will also be down, because velocity gives momentum its vector nature. Note these following words: dropped, released, from rest. All these words, whenever you see one of these 3 words, you must know that the initial velocity of that particular object has to be 0 meter per second. Right, and also maximum height. It means the velocity at that particular point at maximum height has to be 0. Let me show you the scenario. Velocity, the ball is projected up. It reaches its maximum height. Velocity at maximum always has to be 0. Okay, so I will teach you more about this, but as for now, I want you to be familiar with these words, these following words. All right, now change in velocity. In fact, here I meant to say change in momentum. Okay, but we'll deal with that later. All right, so you have seen momentum in horizontal direction, momentum in vertical direction, right? So we're going to do a lot of problems in these cases, so horizontal and vertical motion, right? And we'll later deal with change in momentum. But as for now, I hope we are done with our introduction of this concept of momentum, right? I hope you understand this, and if there are questions you're going to ask on the comment section, you can just ask any question and I will happily answer your question. So I forgot to tell you this. Oh, maybe I did tell you on my introduction. I'm a teacher by profession, so I teach physical sciences, and I may not know everything as it's impossible to know everything, but I know a lot of things in this area of physical sciences. So whatever I'll be teaching you here will also be in alignment with what will be asked in the exam. So I know a lot of these of things in this particular subject. All right. Thank you.